Now that we have studied the basics of exponents, let's understand a few laws related to exponents. We know that 2 raised to 2 is 2 multiplied by 2, and 2 raised to 3 is 2 multiplied by 2 multiplied by 2. In the first case, we multiply 2 2's since the exponent or the order is 2. And in the second case, we multiply 3 2's since the exponent is 3. Now let's say we want to multiply 2 raised to 2 with 2 raised to 3. Observe that the base in both the cases is the same. It's 2. This can actually be solved in two ways. Let's see the first way. 2 raised to 2 can be written as 2 multiplied by 2. And 2 raised to 3 is 2 multiplied by 2 multiplied by 2. And this can be written as 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2. Since 5 2's are multiplied, this product can be written as 2 raised to 5. What we did here was simple. We just expanded the exponents. We wrote it in the simplest form and then counted the number of 2's in the end. Now let's see another way of doing it. The base in both the cases is 2, and the exponents are 2 and 3. So this can directly be written as 2, which is the common base, raised to 2 plus 3. The sum written here is the sum of the exponents 2 and 3. We kept the base same as the base in both the cases and just added the exponents. This is called product law. And this expression equals 2 raised to 5. We get 5 here since the sum of 2 and 3 is the exponent. This method in which we can add the exponents of two numbers with the same base is called the product law. Also remember that what we are finding here is actually the product of two numbers. So when you see two numbers with the same base being multiplied with each other, you can conveniently use the product law. Also observe that the product law has made our life much simpler. We avoided writing so many 2's and got the correct answer in just one step. Now let's try and reduce it to the general form with variables. So the product law says a raised to m multiplied by a raised to n gives us a raised to m plus n. Again, remember that this law holds true only if the base of both the numbers is the same. This law holds true in all cases, but may not hold true when the base is 0. So remember, the product law says a raised to m multiplied by a raised to n gives us a raised to m plus n if a is not equal to 0. So when we are multiplying two numbers with the same base, we should add their exponents. This is the product law. So let's try out a few problems using the product law. The first problem asks us to express this in exponential form. 3 raised to 7 multiplied by 3 raised to 14. Since these two are multiplied and have the same base, we can use the product law. Why is it called the product law? It's simply because it deals with the product of two numbers. Using the product law, we can write this as 3 raised to 7 plus 14, which gives us 3 raised to 21. If we did not have the product law, we would have to write 21 3's in our notebooks to arrive at this final answer. Let's get the next problem. 5 raised to 78 plus 5 raised to 24. Using the product law, this can be written as 5 raised to 78 plus 24, which equals 5 raised to 102. Correct? Wrong. Yes, the base is same, but notice that we have an addition sign here, and product law can be used only for multiplication or product as the name says, not for any other operation. What about 5 raised to 4 multiplied by 6 raised to 4? We cannot use the product law here since the base is different. Base here is 5 and the base here is 6. It doesn't matter if the exponents are the same. If the base is different, the product law cannot be used. But can only two numbers be multiplied using the product law? Not necessarily. If we have an expression like 4 raised to 3 multiplied by 4 raised to 2 multiplied by 4 raised to 5, we can use the product law. Same base and product. So this can be written as 4 raised to 3 plus 2 plus 5, which equals 4 raised to 10. So the product law says that while multiplying numbers with the same base, add their exponents.